by saying, once we have a definition of a population that we're interested in, how do we predict whether those populations will grow or shrink? And can we actually quantitatively predict by how much? And that requires modeling. And as you might imagine, now we're working with mathematical models for the first time in this class. So today, we're going to write a formula describing the growth of a population. And we're going to apply this exercise to a population of animals that everybody loves. Who doesn't love killer whales or orca whales? You go to SeaWorld, you may have seen one of these things performing. If you're lucky enough to have gone on a whale tour in the Pacific Northwest, you might have actually seen one in the wild. I have not, but would love to do so. Now, the thing about these whales is they're very well studied. And off the coast of the Pacific Northwest, you can see here, grab my pencil, that we've got Canada and the US. And it's showing that there are two populations in the shaded areas here with some little bit of overlap. And the reason why we call these distinct populations is because these are groups of whales called pods which travel together. And so while they might overlap in range for some period of time, biologists consider these to be distinct groups, distinct enough that they would keep track of the numbers separately. And so we've got the northern and the southern population. And you can see on this blow up here a map of their population growth. And so you could see from the period from 1975 to 2005, biologists were going out annually and estimating the number of whales in each of these groups. One of these populations, if I had to sort of summarize it, was more or less flat over that period of time. There wasn't a lot of growth or a lot of decline. It bounced around a little bit, but it was relatively flat. The other population, again, if I was going to summarize it very simply, increased fairly steadily throughout that period of time. And so there's clearly a difference in the behavior of these populations, which would suggest that the individuals in them were surviving and reproducing very differently. So let's start to think about how biologists would gain this kind of information and what kinds of factors might they be looking at. So to do this, in other words, I'm saying, what processes determine a population's growth? Why do we see that one population is growing and another one is shrinking? What are the things that might be different or happening differently in these two populations? Well, if you followed along in your textbook, you would remember talking about 4 different processes. And as the growth of a population depends on birth, the number of births in the population, right, which is reproduction, makes sense. It's adding individuals to the population. It also depends on the number of individuals that are no longer with us, the deaths in the population. So as individuals die, they leave the population, subtracts from the population growth. We could also think of individuals not being born or dying, but moving around. So moving from some population into this population, and those are immigrants. And likewise, there's individuals that may be moving from this population out into other populations, and those are emigrants. And if we add together these 4 terms, births minus deaths plus immigrants minus emigrants, this would give us the change in the number of individuals. So clearly, we can think about these processes and how each one would uniquely contribute to whether the population would grow or shrink. Let's do that, actually. Rather than me tell you, let me give you a scenario. This is the plot of the number of whales in one of those populations, and what I've done here is blow it up so it's easier to see. And you can see that what's going on here is that the numbers are bouncing around. This is actually that southern population that looked pretty flat. But if we blow up the y-axis, right, we can actually make it look like there's periods of up and down, because what was happening over a long period of time is doing that. It was relatively flat, but there was a slight wiggle. So now we've blown up the axis so that the slight wiggle is pronounced enough to see. And what I want to point out here is that there was a period of time where the population was dramatically declining. And this looks like just a few years, fewer than 10 years for sure, fewer than 5 years even, where the population was really precipitously declining. So the question I want to ask about this is true or false. The shrinking population between 1965 and 1970 could have resulted from a decrease in the birth rate or an increase in the death rate.